We're going to do another example of using long division with polynomials. So what we're doing is dividing polynomials. There's a video already with an example in the process that you follow. It is not exactly, but it is similar to long division that you learn in grade school. Say we were asked to solve 3x to the fourth and negative 3x squared positive 5x divided by, and then a binomial x minus 2. I know that my numerator will be my dividend and my denominator will be my divisor, but what I notice is that I know my powers are usually going to be written in descending order, and there's a few that are missing. I actually don't have an x cubed, and I don't have a constant. So what I need to do is add them. The way you add them is you make their coefficient 0 so that mathematically you're not actually changing this expression. So we would have 3x to the fourth, a positive 0x cubed, a negative 3x squared, a positive 5x, and then a positive 0. I'm trying to think. I think we could just get away with adding 0. Technically, it would be 0x to the 0 power, which would just make it 1. I think just as far as adding your constant, just knowing there's something tacked on there to the end, it really doesn't matter if you do 0x to the 0 power or if you just write your 0. Okay, so I'm just making sure that that's correct, or if I do the x. Once I get there, I'll notice whether I need to do x to the 0 power or not. My denominator is x and a negative 2. Try to zoom out just a little bit. I know that my numerator will be my dividend, which means it's going to go underneath. I've got a negative 3x squared, positive 5x, positive 0 for now. I'm going to divide that by x, negative 2. Okay, so what we do is you take the first term of your polynomial, that's your dividend, which would be 3x to the fourth. You're going to actually divide it by the first term of the binomial of the divisor, which is x. And that quotient, because what you want to do is make sure that you line up your common terms so that whenever we combine them, they are already above each other. And so if you do that division using exponent rules, I would do 3x to the fourth divided by x. For my coefficient, I would get 3, wrong color. Let me go ahead and take those off. For my coefficient, I would get 3, and then exponents rules state that whenever you divide variables, what you do is you keep and subtract. So 4 minus 1 is going to give you 3. Okay, so the step that we do here is we actually take our quotient, and what we're going to do is multiply it to each of these terms in the binomial individually, and we're going to write them underneath these two terms. Okay, so if you do 3x cubed times x, you get 3 times 1 is 3. Signs are the same, so it's positive. X cubed times x, another exponent rule. When you multiply variables, what you do is you keep your variable, you add your exponent. So do you notice how that became x to the fourth? And so I've got my common terms lined up. Now what you do, I did not erase that blue, and I don't know how easy it's going to be. Not easy at all, very ugly. Hopefully you could still see that. Now what we do is our 3x cubed times our negative 2. 3 times 2 is 6. Signs are different, so it's negative. There is a way to explain that this is actually 3x cubed times 2x to the 0 power. Anything raised to the 0 power is just 1. So what you get is 3x cubed times 2. And so in that product, I have a variable cubed, which just means that, in my multiplication, I have a variable cubed, which means in my product, I'm still going to have a variable that's cubed. But that's very mathy and honestly unnecessary. If you just know that when you multiply um, your term here with your term here, you're going to look at the coefficients, and then my x cubed is just going to remain an x cubed. It's not being multiplied by another variable, so technically my exponent will just stay the same because it's not being added to anything. You draw your line here, and then this is where we change the signs, whatever they previously were. You write the opposite. If you look at your first terms, I have additive inverses. What that means is that it goes to 0, which is great because that's actually the goal there. And then if you look at your second terms, I have a 0x cubed and a 6x cubed. Those numbers are both positive. So what you do is you add and you keep, and then whenever you combine like variables, like terms, what you do is you keep and you keep. Okay, so that's going to end up being 6x cubed. So second verse, same as the first. What we do is we take this term right here, divide it by this term right here with your quotient going here. So if you do 6x cubed divided by x, well, 6 divided by 1 is going to be 6 signs. 6 signs are the same, so it's positive. Then x cubed divided by x, when you divide, you keep and subtract. Now we do the multiplication. And what you multiply is the quotient you just found by that binomial right there. So individually, we do 6x squared times 6. So we would get 6, keep, add. Let me go ahead and bring this down. That's a negative 3x squared. Excuse me. Now we do 6 times a negative 2. 6 times 2 is 12. Those signs are different, so it's a negative 12. And then don't forget your variable with your exponent. Now we do our line here, and we change the signs. If you notice, first terms, again, additive inverses, just a heads up, that's what should happen to those first times each time. If not, maybe you forgot to change the signs, or you had an error somewhere in either your division or your multiplication. So if you look at these two terms right here, we have a negative 3 and a positive 12. Signs are different, so you would subtract, keep the sign of the larger, you get a positive 9, keep and keep. Okay, so now we're going to bring down, don't want to forget that again, bring down whatever term you have here, you write the exact same thing, same sign, same everything. Now we're going to do the division of our 9x squared by our 9. So 9 divided by 1 would give you 9, and it's positive. X squared divided by x is keep and subtract, so I just get a 9x. And then we're going to do our multiplication. 9x times x would be a 9x squared. Also, heads up, not only do they become 0, the only way they're going to become 0 is if they're the same term. So if you've noticed, I've gotten the exact same thing here each time. Okay, if you do 9x times a negative 2, 9 times 2 is 18. Signs are different, so it's negative 18. And then what you do is you don't forget your variable. I'm going to scoot up though, see if I can get smaller. Okay, so you are going to draw your line right here, change your signs, notice the additive inverse. If you combine these, they have the same sign, so I would get a positive 23x. Yes. And then what I do is I need to bring down, I want to erase this right here. Okay, I need to bring down my 0. So that would go right here. And then I'm going to use this first, the actual term, not the 0, but that first term. You don't need to write the 0 each time. I just do so you can see what's happening. But now let's take this 23x and divide it by our x. 23 divided by 1 is 23. Those signs are the same, so it's positive. x divided by x, what you do, x divided by x, you keep and you subtract, which would give me x to the 0, which is just 1. So technically, x divided by x, it's like their inverses almost. They kind of cancel each other out in a way. You end up getting 0. So we do not have a variable attached to that 23. Now this is where we do our multiplication. 23 times x is 23x. 23 times 2 is 46. Signs are different, so it's negative. Draw your line, change your signs. Try to make this smaller. Now, if you look right there, you notice that we have additive inverses. They go to 0, and then 0 plus 46 is just 46. And then that's it. I have nothing else to bring down, and we definitely would not start working with decimals here. So once you get a numerical value here, if it's 0, there is no remainder, but you would just write your 0 over your divisor. Here, I do have a remainder of 46, and then the actual answer would be 3x cubed, a positive 6x squared, a positive 9x, a positive 23, and then we're going to add to that our remainder, which is 46, over our divisor, which is x minus 2. That is the answer to the division of those polynomials. Okay, so I'm going to do one more. Say we have, it asked me to, let me zoom in. There we go. Zoom in a little bit more than that. It asked me to divide 3x squared, they have it in parentheses, plus x and a minus 4. And they have the division symbol right here, and I'm dividing that by x minus 1. So what you do is you take your, let me look, I do have an x squared, an x to the first, and then an x to the 0 power, right, because it's just a constant. So I'm going to take my 3x squared plus x minus 4. I'm going to divide it by x minus 1. So what you do is you're going to take your first term under which of your dividend, right? And you're going to divide it by the first term of your divisor. 3 divided by 1 would be 3. X squared divided by x gives you x. That means I know my variable of my quotient is x, which means it needs to go here. This is so that your like terms are lined up. Now what we do is the multiplication. 3x times x is 3x squared. 3x times 1 is a negative 3x. Draw your line, change your signs. I get 0. And then 3x plus a 1x, signs are the same. You add and keep the same sign, which would be a positive. And then because we're combining variables, you keep your variable, keep your exponent. Okay, do division. 4x divided by x would just be 4. Signs are the same, so it's positive. After I do that, I'm going to bring down this term, which is a negative 4. I'm still looking at my first term because that's the one I'm trying to cancel, right? I've already done my division. I pulled down the next term. Now this is where you do the multiplication between these terms. So if you do 4 times x, you get 4x. 4 times 1 is 4. Signs are different. So it is going to be a negative. And then you draw your line, change your signs. So if you notice here, I've got an additive inverse with this term, these two terms, right? The difference of these terms. And then my minus 4 plus 4, those are also additive inverses. So that also becomes 0. So what you would get for the answer here, they, I think, have it in the form of just 3x plus 4. It is not incorrect to write it like this, but you'll notice in the homework they may change the form of their answer. It could be because they actually don't want you to write the remainder over the divisor. It could be that they specifically ask for just the quotient. This would be your quotient. This would be your remainder written over your divisor. Both of them are correct. Even if that's not a 0, right? They would both end up being correct. I did just notice, though, that this example only wrote down the actual, 3x plus 4. It had nothing to do with the remainder. It could say that if your remainder is 0, just write this part. So just really pay attention to the directions. And I guess that's honestly it. There's going to be, I don't want to say a second half to these problems, but there is more to these problems. So I will do some more videos. And if y'all have questions, make sure you ask me. Thanks.